Okay, now we were in this question, we'll discuss how to find this one. Okay, in main hardware stores, buck nuts and bolts are sold by weight. Spring scale in stores reaches 4.8 cm when 24 Newton of bolts are weighted. On the scale, what is the distance in centimeters between calibration marks that are marked in increments of 1 Newton? So he's asking us for how 1 Newton how much this will increase, which means this one here spring how much it will increase in centimeter or meter from 4.8 if you add 1 Newton. Okay, so we have 24. This is like direct variation but just a little bit advanced. Okay, this is we have 24 that are pulling by the gravity down, and because it is in equilibrium or it is in equilibrium state, that means the scale is pulling by 24 Newton. Okay, so let's go find first k. K is the spring constant of this spring, so k is equal to minus fx over x. So we have here 24, this one, and we have here how much? 4.8. But one of them is negative, and we have the negative of the formula, which should be negative 24 or 4.8. The force is negative because it's opposite for the extension. So minus minus, this is positive, and this will be how much? This is centimeter, by the way, and this is Newton. So let's do it anyway, but we have to remember this is centimeter. So it will come 5 Newton per centimeter. Okay, don't forget this one, 5 Newton per centimeter. So let's go find x now. X minus fx, which minus over k, right? So fx is now, we will have 1 minus 1 Newton over k is how much? 5 Newton per centimeter, and this will give us minus 0.2 centimeter. Okay, which means we have to add for 1 Newton we have to add 0.2 centimeter in order to make it in the calibration. Okay, now let's go and do another example. In a dart gun, a spring with K is equal to 400 Newton per meter is compressed 8 centimeter when the dart mass of M is equal to 10 gram is loaded. What is the muzzle speed of the dart when the speed is released? Ignore friction. Okay, we have this one before and after. Always we have window, we have conservation of energy. So when we have conservation of energy, what you have to do is you have to find Ki plus Ui is equal to Kf plus Uf. Okay, so Ki is what? Ki means you have for the first before. Okay, before kinetic energy before. So kinetic energy before is half mv final square. Sorry, this is not final, this is initial. Sorry, initial. Okay, the one we want to find is the v final. We want to find the v final. Okay, the final velocity of the dart. So half mv initial square plus the u initial is the elastic potential energy for the first or before the dart go. So this is half kx square, the first extension. Okay, is equal to kf. Kf means the velocity final. So the velocity final is not the velocity, is the kinetic energy final. Alright, so half mv final square plus for the u we have half kx square. So for this one, because we don't have movement here because the dart is 0, it doesn't have any speed, that means this one is 0, so all of this will be 0. But for this one we have extension, which is how much? Here it is 8 centimeter, but we will not take it in centimeter, we will take it in meters. That means 0.08. So half k is how much? K is 400 Newton per meter. So x is 0.08 square is equal to, for this one x is relaxed. Now the spring is relaxed. Now the speed is relaxed. Because the speed is relaxed, now x will be how much? X will be 0. X will be 0. Now x, because it is 0, k like always we have 400, but because x is 0 it will eliminate this formula. Because it eliminates this formula, we will have this one. So half Mass is how much? It's 20 gram, so we have to change it to kilogram. So it will be 0 point how much? 20 divided by 1000. So this will be cancelled, and this will be 0 0.02 kilogram. Okay, kilogram times V final square. V final square. So this one is divided by this one, 200 Newton per meter times 0.08 square. So 0.08 square is equal to, if you divide this one, this will be 0.01 V final square. Okay, so we have V final square. So in order to find V final, what we have to do is 200 times 0.08 square divide by 0.01 and square root. So if you find this one, this means how much? 200 times 0.08 times 0.8 divide by 0.01. So it came like V final square root of 128. So V final is how much? Now square root of 128 is 11.3 meter per second. Now this is the speed of the dot when it is released from the spring. Okay, now we finish here for the part 1. For the part 2, we'll start from the elastic potential energy, application of energy conservation with jumping. Okay, thanks.